Okay, so we are given the challenge here. The challenge says using Python, implement a recursive algorithm to evaluate any algebraic expression. The algebraic expression will be input as an immutable string, and the output of your algorithm should also be an immutable string. Please implement any data structures that will make the process of evaluating expression more efficient. So what we are going to do here, we are going to implement a recursive algorithm to evaluate any algebraic expression. So the meaning of immutable string, it means that the content of the string object can't be changed once it is created. So it is said that an algebraic expression would have the following. It would have the operators, which are addition, subtraction, multiplication, division, and grouping. Then we talk of operands, which are numerals, which are floating point, um, complex numbers, and also integers. Then we have these are valid expressions and these are invalid expressions. So to solve to so I'm going to use Bodmer's rule to answer the question. So I'm going to use Bodmer's rule to answer the question. So Bodmer's rule stands for brackets of addition, brackets of division, division. Then we talk about multiplication. Then we talk about, the spelling is incorrect, I'm sorry. We talk about multiplication. Then we talk about addition, addition, and then we talk about subtraction. So I will indicate how this Bodmer's rule work. So this is how it works. Let us look at this expression. Looking at this expression, this is how Bodmer's rule work. So Bodmer's rule, it shows the order of precedence of these operators. So looking at this expression, so here to find the solution of this expression, we will start by division, because here Bodmer says division, multiplication, addition, then subtraction. So here we have division, multiplication, addition, and addition. So we'll start with division, then we'll come with multiplication, then addition, meaning that we'll say 3 divided by 12 and we'll get an answer. After getting that answer, we'll say 12 multiplied by that answer that we got here. Then after that, we get an answer here. So we will say 3 plus the answer that we got here. So the approach that I'm going to use to here is the approach that I'm going to use here is called the reverse Polish notation. It's called the reverse Polish notation. So I'm going to explain what is reverse Polish notation. So reverse Polish notation is also called postfix. So this is notation in mathematics that wherein operators follow their operands, meaning that we start writing the operands and then we come by operators. So I will show it for I will demonstrate it for I will demonstrate it so that it can be understandable. So I'll copy this expression and paste it here. So what reverse Polish notation does is that we are going to say, so let's say we are requested to write this as in reverse Polish notation. So what we are going to do is to start with operands, and then we will finish by writing the operators. So let's just do that. Operands, then when we are writing operands, we will start from the leftmost side and going to the rightmost side. So we will start from the leftmost side. So we'll start by 3. I'm going to write brackets to avoid confusion, and then 12, and then 3, and then 12. So this is how we write operands in reverse Polish notation. Then after that, we're going to write operators. To write operators, we start from rightmost side of we start from the rightmost side to the leftmost side. So we will start by division. We're starting from the right. The first operator from the right is division, then the second one is multiplication, then the last one is addition. So this is how we write a reverse Polish notation or a postfix. So how do we do calculation in a postfix? So we, after writing this, we'll come to these two last numbers or last operands, then we will perform or we will apply the first operator. So we are going to say 3 divided by 12. So we'll get an answer. Maybe let's call that answer C. C. So then we will go to these two operands again, then we will apply the next operator that is following the division operator. So it's multiplication. We're going to say 12 multiplied by C, which is going to be, let's name it, an answer is going to be B. So the lastly we are going to say we're going to say 3 plus B, and then we will get the final answer. So that's how we write, that's how we perform, or that's how we do reverse Polish notation. So I'm just going to copy to rewrite the reverse Polish notation. So 12. So another thing here that I'm going to do is I'm going to use stack data structure. So I'm going to use stack data structure. So I'm going to stack operands and I'm going to stack operators. So I'm going to write operand stack and operators stack. So let us write it. Operands stack, operand stack. Then to write operand stack, we will go again to the expression that we are given. For us to write a stack in data structure, where the first operand is going to be at the bottom of the stack, and the last operand is going to be at the top of the stack, meaning remember we're looking at the operands only because we are writing the operand stack. So meaning that we are going to say we are going to start by 3. The operand at the left of the leftmost side is going to be at the bottom. So meaning that we'll write 3, then it is followed by 12, then it is followed by 3, then it is followed by 12. So this is how we are going to do it. Then after that we'll write the operators stack. To write the operators stack, we do the same thing that we did on the operand stack. So here we're going to look at the operators only. So what we are going to do, we'll start at the leftmost side of the or of the expression. So meaning that it's going to be the one which is going to be at the bottom is going to be addition, and is followed by multiplication. The one which is going to be at the top is going to be division. So at the bottom of the stack, addition followed by multiplication, and the one which is going to be at the top is division. Yeah. So again, we are going to define a function. So I'm going to create a function, and I'll call that function evaluate expression. That function is going to evaluate the expression that we are given. Okay, let's define it. So I'm going to say def evaluate underscore expression, and that expression is going to take in the parameter expression. So again, I'm going to evaluate I am going to define a helper function. I'm going to define a helper function, so it's going to be like this: helper function. So this helper function is going to that will evaluate sub expression. Is going to evaluate the sub expression. So I'm going to define that if that expression that is going to evaluate sub expression. I'm going to define that function. So def that helper function evaluate underscore sub expression. So this sub expression is going to take in the parameter sub expression. So again, it is going to return an answer, and here I'm going I'm sorry, here I am going to call I'm going to call the evaluate expression, and then after calling it, I want it to be in the form of a string so that it can cover all integers, all numbers, and yeah, so it will take a parameter of sub expression. So I'm going to do it like this because I want it to be in a form of string. Sorry, evaluate underscore expression, um, and then this expression is going to take in sub expression and so again I'm going to call, and I'm going to define another helper function that will perform basic operation. So let's define it. Def perform underscore operation, and this one is going to take three parameters, which is the operand 1, operand 2, operator, the operand 2. So we will write if statement to take care of this operation, so to show how this operation is going to work. So let's say if if operator is if operator is addition, then we are going to return then we are going to return answer in string, so that it will cover all integers. And then return string, I will write string operand 1 plus operand 2. So I will write this in a form of float because I want it to cover all numbers. So operand 1 plus plus operand 2 plus operand 2. So again here I'm going to write else if the operator, let's copy this, if the operator, and paste it here, and if the operator is subtraction, then it is going to return operand 1 minus operand 2. That's how it's going to do it. So we need to be careful when writing this operand spelling. It has to be the same. Yeah, so after that then we will copy again this elif. We'll copy this elif again, then we will write multiplication, then here is going to perform multiplication, then we will paste elif again, here we write division, then it's going to perform division here. Since we will be using reverse Polish notation, I will create an operand stack and also operand stack. So let us create operand stack and also operator stack. Operand stack and also operator stack. So here as a comment, I'm going to write stacks. So to create stacks, I'm going to say operator underscore stack. I'm creating an operator stack, then at the beginning it will be empty. So I'll also create operand stack. So to create operand stack, at the beginning is going to be empty. So be careful with the spelling here. You see the spelling are not the same, so it will be a problem. So yeah, operand stack. So after that, the next step I will write order of precedence. So I'm going to write this order of precedence of the operators, right? I'm going to write order of precedence of the operators. So to do that, I will create a precedence variable, and it's going to be in a form of dictionary. Let us create it in a form of dictionary. So I will say precedence. So let us perform the order of precedence. So I will start with addition, then addition I will give it 1, I will give it 1. Addition, I will give it 1. Addition, I will give it 1. So you're supposed to write it like this. Like this. Addition, I will give it 1. Then we come to subtraction. We come to subtraction. Then we'll come to subtraction. Then on subtraction, we are going to give it the value of 1 again. Then also we will come to multiplication, and we are going to give it the value of 2, since using BODMAS rule. Remember here, BODMAS rule, brackets, division, multiplication, addition, and subtraction. So that's what we are doing here. So we'll also do division. Then division, we're going to give it the value of 2, right? Then we are done with order of precedence. So after that, we need to iterate through our expression. So the expression that is going to be provided once we call the function. So we are going to use a while loop. So say while I is less than the length of expression, while I is less than the length of expression, while I is less than the length of expression, I'm sorry. So we are going to say we want to get any expression at index I, and we are going to assign it to a variable char. So we want to get any expression. At index I, and we will assign it to variable char. We will assign it to variable that is called char. Or char. So we're going to initialize I to be equal to 0. I to be equal to 0. Then what we're going to do now, we are going to check whether the characters these characters have digits or they have decimal point. So we're going to do that using if statements. So we're going to say if char is digit is digit, or char have decimal point in it. It means that, or char has decimal point in it. It means that it is a decimal. It is a decimal. So we are going to check that whether the characters have digits or they have decimal point using this if statement. Okay, so then we are going to extract the entire operand from there. So then we will write another while loop inside so that it can be able to extract the entire operand. So what we are going to do here, we are going to the characters that are on the second operand, we will call them J, and J, we will initialize J, and we will set J to index I. So J is equals to index I. Then we will write the while loop. So we're going to say while j is less than j is less than the length j is less than the length of expression um and we are also going to check whether j has digits or decimal point. So we are going to copy this and paste it here to check whether j also have digits or decimal point. So this is what we are going to do, and we are going to increase j by 1 so that as iterating through it will move ahead and pick the following elements. So I'm going to say j j plus equals to 1. So after that, we are going to extract the entire operand. So we are going to say at the comment extracting the entire operand. So what we are going to do, we will stack the expression. We will stack the expression from index I to j and assign it to what, to operand. So make sure operand spelling matters. So I'm going to say I'm going to stack expression from index I to j and assign it to operand. I'm going to assign my expression to operand, and then I'm going to extract it from index I to index j. I'm going to extract it from index I to index j. Okay, so we are going to call the operand stack and we are going to append a specific operand on the operand stack. So we are going to say operand stack operand underscore I'm sorry about my bad language. Operand underscore stack then dot append we are going to append a specific operand. We're going to append a specific operand. So after that, we will be able to pick the entire operand, and we will be able to say whether it is a decimal value, int, and all that. So now after doing that, the index of I and the index of j are going to be quite the same. So the index of j is going to be quite the same with the index of I. So after doing that, we are going to check for operators. So we are going to check for operators. When we're doing that, meaning we're going to write a set containing all those operators. Then we will define the precedence of operators and all that. So we will have the character in this set. So we will write the set like this. Elif, else if else if the character in this set of operators where we talk about addition, then we go to talk about subtraction, then we go to talk about multiplication, then we go to talk about division. Then yeah, Then so we will take the operator stack and the precedence. So we'll, before that, we will define a precedence of these operators using a while loop. So we will take the operator stack and the precedence. So we are going to say um, we're going to say while the operator stack, the operator while the operator stack um, and while the operator stack and precedence and precedence, yes. So we will, for precedence, we will use indexing and take operator stack at index -1, meaning that it will take it from tail backwards. So we will say precedence. It will we will take operator stack. We will take operator stack, operator stack. We'll take operator stack of at index -1. Then we will see all this is going to be greater than or equals to the precedence of the current character. This is how we're going to write it, of the current character. So here we will pop out the operators and the operands. We will pop out the operators and the operands out of the stack. So we will pop out the operator first. Let us pop out the operator. We're going to say operator. We're going to say operator. We're going to say operator operators from the operator stack. Then we're popping it out from the operator stack. Then we will pop the second operator. We'll start with the second operator. So we will start with the second operand, not the second operator. I'm sorry. We'll start with the second operand 2. Then we will pop it out of the stack. Operand stack. Then we will pop out the third operator. The first operand. So operand 1, we pop it out. Operand